In this video, market basket analysis and a priori algorithm will be covered. Market basket analysis. Frequent item set mining leads to the discovery of association and correlations among items in large transactional or relational data sets. With massive amounts of data continuously being collected and stored, many industries are becoming interested in mining such patterns from their databases. The discovery of interesting correlation relationships among huge amounts of business transaction records can help in many business decision-making processes such as catalog design, cross-marketing, and customer shopping behavior analysis. This analyzes customer buying habits by finding associations between the different items that customers place in their shopping baskets. The discovery of these associations can help retailers develop marketing strategies by gaining insight into which items are frequently purchased together by the customers. The support of A and B is defined as a P of A union B. Confidence A and B is defined as a probability of B then given A. The rules that satisfy both a minimum support threshold, that is given as a min sub, and a minimum confidence threshold, min conf, are called strong. A set of items is referred to as item set. The occurrence frequency of an item set is the number of transactions that contain the item set. If the relative support of an item I satisfies a pre-specified minimum support threshold, and that is the absolute support of I satisfies a corresponding minimum support count threshold, that is I is a frequent item set. In general, association rule mining can be viewed as a two-step process. Number one, find all frequent item sets. By definition, each of these item sets will occur at least as frequently as a predetermined minimum support count or min sub. Second, generate strong association rules from the frequent item sets. By definition, these rules must satisfy minimum support and minimum confidence. Maximal item set is an item set is maximal frequent if none of its supersets are frequent. Then second, closed item set. An item set is closed if none of its immediate supersets have same support count, same as item set. Third one, K item set. Item set which contains K items is a K item set. So it can be said that an item set is frequent if the corresponding support count is greater than minimum support count. As given in the screen, A is closed because none of its supersets have the same support as itself, but A is not maximal because A, D is a superset of A and is frequent. Now find the remaining frequent item sets. A, C, E and AD are closed frequent item sets. Also CE and AD are maximal frequent item sets as per the example. All maximal frequent item sets are closed frequent item sets, but all closed frequent sets are not maximal frequent item sets. Pattern mining based on the completeness of patterns we mine. Example, closed frequent item sets and the maximal frequent item set, constrained frequent item sets, etc. Based on the levels of abstraction involved in the rule set. If customer X is going to buy a computer, he is going to buy the HP printer also. Another example, if the customer X is going to buy the laptop computer, he is going to buy the HP printer. Based on the number of data dimensions involved in the rule, single dimensional association rule, multi-dimensional association rule. If customer S is buying a computer, then he is going to buy the antivirus software. This is one dimensional association rule. Then if a customer X age is between 30 and 39 and the income of the customer X is 42,000 and 48,000, then he is going to buy the high resolution TV. Based on the types of values handled in the rule, example is Boolean association rule, and quantitative association rule. Based on the kinds of rules to be mined, example, association rules and the correlation rules. Based on the kinds of patterns to be mined, sequential pattern mining and structured pattern mining. Frequent item set mining methods, a priori algorithm is given. It is for mining frequent item sets for Boolean association rules. A priori property is all non-empty subsets of a frequent item sets must also be frequent. In the given data set, 9 transactions are available and different item I1 to I5 are purchased by the customer by using in different 9 transactions. Two steps are involved in this a priori algorithm. One is the join step, second one is the pruning strategy. The resulting pruned version of C3 table is shown as the first table of the bottom row. Step number 7. The transaction in dataset D are scanned to determine the L3 table consisting of those candidate 3 item sets in C3 table having minimum support. Step number 8. The algorithm uses L3 table will be joined with the L3 to generate a candidate set of 4 item sets, that is C4 table will be generated. Although the join results in I1, I2, the I3, I5, item set I1, I2, I3, I5 is pruned because its subset I2, I3, I5 is not frequent. The C4 is empty and the algorithm terminates having found all of the frequent item sets. Priori algorithm is applied on this example also. The first table on the top row, database D containing 4 transactions, then it is scanned, then it is finding the support count for each and every item. Item number is 1 to 5. The support counts are given. Then based on the minimum support count, it is pruning action is done. Then L1 table is created. From the L1 table, again we are going to join the L1 will be joined with the L1, then C2 table is created. From the C2 table, again the pruning, it's going to find out the support count, then C2 table is here. Then from the C2 table, again pruning action is done. Then greater than minimum support count only will be considered in the L2 table. From the L2 table, again L2 table will be joined with L2 table, then C3 is created. C3 containing the item set 2, 3, 5, then scan the data set D, then the L3 table will contain the support count also. Note that 1, 2, 3 and 1, 2, 5, 1, 3, 5, 1, 3, 5 not in C3. Then the algorithm will be steps of a priori algorithm. Generation of candidate item sets for C1. Check for the required minimum support count of the transaction. The set of frequent one item set L1 is generated from C1 that satisfies the minimum support count. Discover the two frequent item set by L1 is joined with L1 and generate C2. L2 is generated by pruning the records that do not satisfy the minimum support. Step number 6. Discover the three frequent item set by L2 is joined with L2 and generate C3 table. Step number 7. L3 is generated by pruning the records that do not satisfy the minimum support. Then step number 8. Discover the 4 frequent item set by L3 is joined with L3 and generate C4. Step number 9. The algorithm ends the frequent pattern mining if 4 frequent item set is not available. For frequent item set L, generate all non-empty subsets of L. For every non-empty subset S of L, output the rule S, then L minus S. The minimum confidence, where minimum confidence is the minimum confidence threshold. Generating association rules for frequent item sets. Generating association rule, let's try an example based on the transactional data given earlier. Suppose the data contain frequent item sets L equal to I1, I2, I5. What are the association rules that can be generated from L? The non-empty subsets L are I1, I2, I1, I5, I2, I5, I1, I2 and I5. The resulting association rules are shown below. Each is listed with its confidence. I1 and I2 then gives I5. That confidence is 2 by 4, 50%. Likewise, for all the subsets, we are finding the confidence like 50%, 100%, 100%, 33%, 29%, and 100%. from the generated association rule, only the above the threshold value, only the three rules are accepted. Rule number 1, rule number 2, and rule number the last one, rule number 6. So this is greater than the threshold conference value. So these are accepted, other rules are rejected.